Hello again. Today we will be continuing the work on the priority index for the search engine. And previously we have removed some data that was interlaced with the document IDs, and we have removed the B-tree components from this index as well. It should probably not be called an index anymore, since it's just a list of document IDs now. But I guess in some sense it is an index from keywords to document ID listings. So we'll keep the name for now. And so far we have shrunk the files quite considerably. Originally they were 174 gigabytes, and now in the last step they are at 85. And this is obviously an improvement, but I did some thinking, and I think we can actually get it down to like 20 gigabytes using a compression algorithm. And you might think that actually compressing and decompressing the data is going to make this slower, but in a modern computer architecture, you have usually the bottleneck for this type of application is the IO throughput, and then much faster than that is the main memory throughput, and then much faster than that is the CPU caches. And the compression is going to be mostly CPU cache bound. And there's a lot of caveats and it depends instances in this, but in a broad sense, this is correct. So to actually compress this data, sorry, I have a bit of a sore throat today, so you may have me coughing a bit more than usual. So is compressing the index at all viable? But I actually did some testing for this a couple of days ago, and you can't compress like the difference between two document IDs, because they are constructed from 3 different fields, and that means that your differences will have a bunch of different modes. And I did a really crappy graph for this to try to illustrate what's going on. And I have the poop emoji here indicating that I've pulled these numbers from my behind. But this is basically the shape of the distribution. You have a lot of instances where it's just the smaller bits that are increasing, but then this sort of pans down, and then you have another bump, another mode for when the domain ID increases. And if you look at the schema here, you have like the first 26 bits is the ordinal. And I think sometimes I've said document ID for this, but it should be document ordinal, because this is not unique. It's unique within a domain ID, and a document ID is this entire thing combined. But you have the second bump for the domain ID, and this is smaller. And then you have a third bump for the ranking, and the ranking is it's only used in sorting the documents, so that the most important documents appear first, or considered first, so that when we run out of compute, we get the best results. Sorry. Right, so with this in mind, we can't just try to compress the difference, right? We need to invent some sort of a compression codec for it. And what I had in mind was basically to first we write 2 bits that basically select a code, and depending on these 2 bits, we will either encode just this delta, or we'll encode this pairing, or we will encode the entire thing. And then there's obviously, if you have 2 bits, then there's a 4th state here, and we might use it. I don't know. We'll leave it reserved for now. Maybe we will have use for it in like encoding some metadata about the sequence or something like that. I don't know. we will leave it open for now, and obviously having 2 bits means you can actually have add more bits if it's 2 bits. So we will see. But what I found was I haven't actually implemented this, but I implemented a simulation of the compression where I basically added up the widths we would end up with, like bit widths, and added them up and crunched the numbers to see on like real production style data how much space would we save, and what I arrived at was between 20 and 25% the size as the output, so we get like 80% compression, and that's pretty good. It's actually up there with a proper compression algorithm, but this is much simpler and much faster. So that actually answers the next question, like why are we implementing custom compression? Why aren't we using gzip or standard or zipper or something like that? The reason is that we understand the data much better than they do, and they are like general purpose compression algorithms and make a lot of concessions to be able to compress all sorts of data, whereas we understand that this is just a list of 64-bit numbers that have a format, and they have this modality for their bits, how they change, and they are increasing in a monotonous fashion. So there's a lot of understanding we can encode in this algorithm, and hypothetically this should be very fast. This is obviously not implemented yet, so we don't know how fast it will be, and it's possible we may need to make like a native call to C++ to really get the speeds we want, but we will see. And most of all, this is an experiment. We don't know if this is something we want to do in production. Maybe we will delete this code and walk away with an understanding that this is not something we should do. I don't know. Either way, it will inform what we do next with the full index. If we can compress the full index by 8%, that's great, and get like no speed penalty. That would be fantastic. If this is not possible, if this is slow, or if it's not compressing as well as I had simulated, then we will just delete it and walk away. And I expect this will take like an hour or 2 to implement. So it's not a huge waste of time, and even if we waste time, we still gain an understanding, right? Yes. So let's get to it. All right, then let's begin. The first thing I think we should be looking at is this prior doc IDs transformer, which is what we worked on last time. What we want to do is basically add another buffer to this, because we are going to be reading into one buffer, compressing the data, and then writing it to a new buffer, and then writing that to disk. Possibly we want something like I talked about last time. We're currently writing this to disk every time we fill up the buffer. Maybe we don't want to do this. This is an inefficient pattern. Maybe we will look into that. But for now, I think we will just add this additional buffer to ensure that it works. And then we can add a compression step in between. I think that's a good plan. So let's rename this guy read buffer. And then we want the write buffer as well. All right, so and this is where we are doing the writing. So first we want to basically we write the read buffer to the write buffer, and this is compression. We aren't actually compressing yet, but we're just doing it, and then we let's see, will this work? The write buffer is the same size as the read buffer, so we can be sure that this actually fits. And the compressed data should be strictly smaller as well. I think that's fine. All right. Maybe we should actually, because we're going to be compressing this, maybe we should have like a step where we check whether the read buffer fits in the write buffer. Actually, I don't think we can do that, because we won't know how big it is. Let's see here. First of all, let's see if this actually works. This is the guy we want to run, right? A very merely basic sanity check. Right, and it's working. That's great. What can we do next? This is where we should be doing the compression part. And there's a very handy class that's called bitwriter in the repository. And the purpose of this class is to write non-octet aligned binary data to a byte buffer. And this is obviously going to be necessary for what we're going to do. Having some abstraction for it makes life a lot easier, because this is very finicky. So what do we want to do here? We want to create a bitwriter, and we want to actually let's pull up this codec we had in mind. Can we just copy this? Actually, we cannot. Let's copy it from Vim instead then. This work? No, it's intercepting my copy. Let's copy it from less. Right. Let's put this up on the fridge so we have some idea of what we're going to be doing. And I think this reserved for expansion step should be, because we're going to need to tell how many items we are compressing. And this step where we're basically writing a size to the data, I don't think we can do that. We shouldn't do that because we don't know the size beforehand. We can obviously calculate the size of the compressed data, but I think that's going to be very inefficient and slow. Maybe that's a good idea because we're basically paying the cost at construction time. Is that a good idea? I think it will be very slow. I don't think we want to do this. I think we want to use this reserved field, and then we basically have a 32-bit like so. Or maybe we should do like a 30-bit size header, so everything is aligned from there on, maybe. Because we're never going to be like writing gigabytes of documents on the same partition. I know I used a long before, but I think that's very excessive. So that's not something we want to do. Right. And 30 bits is a gigabyte. Yeah, I think that's safe. If we find some keyword with a well, it's not a gigabyte, it's a billion, I should say. Because we're not counting bytes. If we find some keyword with a billion documents on the same partition, then something is really messed up. So I don't think that is something we need to worry about at all. If that happens, then we have much bigger problems. And we should be adding new partitions instead. Because we can't really expect to read back a billion items. That doesn't make sense. That does not make sense at all. So we can actually remove this, and we can remove this. Now we have broken the decoding, but that's fine. We'll be sure that the tests fail when we do this. Yes, they do. Yes, they do. That's good. That means the tests are helpful. Right. And then we need a bit writer. And this needs a work buffer, and it should be a write buffer. I wonder how much we need to modify this guy to do what we want it to do. I'm not sure yet, but first of all, we should be writing a header. So then we can do like so. That's incorrect. We should be writing size L. It's so. Now we have a header in place. Actually, we should be doing this. We should be doing this. I know it's not 63, 61 bits. And then we can like so. We get the first value, and then we... Does this guy not take longs? No, it does not. That's a bit unfortunate. Can we modify it so that it does? No, that's annoying. Let's write it in pieces instead. Perhaps if we do this. Or can we do this instead? Maybe. Let's see if this works. 64. This is not assuming int anywhere. Can we read along? Actually, this is really stupid. I shouldn't be doing this because we're going to be deconstructing this guy anyway. And then we can just basically write the components. We want previous rank. We want previous domain ID, and then we want previous ordinal. Previous rank so. So. And then we can just do it's not 32, I think it should be 7. The main ID is 31. Document ordinal is 26, I think. Can we prove this somehow? It's 26. 31. Yes, I think that's correct. So we are writing it in pieces. This write instruction is a bit slow because we're doing it in pieces, but we need to extract these guys anyway, and that's fine. And this is only happening once per sequence. We don't care too much about efficiency for that part. Actually, these guys shouldn't be in the loop. And I think we need a boolean to determine whether we have written the handler, because we don't want to do this for every time we fill up the read buffer. So this is becoming a bit messy, but we can clean it up later. Like so, maybe. So we are filling up the read buffer, and if we haven't set route header, then we will populate it here, and we will populate this previous rank domain ID and the document ordinal. We have run the first item from the read buffer. And then as long as we still have data in the read buffer, here we shouldn't be compressing it. should be, let's comment this guy out for a moment. And we do get long. Can you do this for me, Copilot? So, thank you. And then we check, and we do the, let's populate this guy so it's not complaining, even though this is like impossible. It can never go past this point without passing this block, so we're always setting them, and then they are always populated when we reach this point. But Java is a bit complaining in that regard sometimes. So where do we have the codec? Let's move this guy down a bit so we can look at it. If rank is different, then we should be writing a header that's so, and then we should be a width of 2. Then we gamma encode the rank, and then we shouldn't be writing the delta. We should be writing the but bits, and then we write the domain ID, and then we write the ordinal, right? So domain ID is different. Can you write this for me? It's almost, no, actually it built the whole thing. Is this correct? Right. Yeah, that's helpful. If you actually prompt Copilot, it can be surprisingly good at implementing stuff like this. Right. And should we be writing this always? I don't think we should be writing it always. We should check how much data is left. It's less than, say, is this guaranteed to always be smaller than 8 bits? I'm not sure it is. There's probably some like worst case scenario where let's put 16 to be safe. So right. Now we have cleared this. What was this guy coming from? Let's check. Let's check what this used to be. We're incrementing this guy, but we should be doing this instead. Almost correct. Let's see. And now we're filling this up. Actually, it's very good that we're doing this, because then we can, at this point, we can do a bit writer. I need to go to the code for this guy. If there's a function toward the end, that's finish. Right. That should position the actually this is not going to be working. Because this guy assumes that he has full access to this underlying buffer, and we're actually we are actually stealing data from this buffer. This is obviously perhaps not the most civilized way of implementing this, but let's see. If we expose this function, which will flush any partially written data to the buffer, that should be fine. And since we are using put long, then we will increment the position, so we can just flip it. Then let's do this. Like so. And there's a chance there will be insignificant data toward the end, just to pad up to the largest, into the long size. But I don't think that matters in this case, because we probably want these to be long aligned anyway. So having some minor gaps there probably doesn't matter. We will need to ensure that it is actually is aligned. Like this. Right offset B. Yeah, that sounds about right. And this is just right. And L, where are we updating this guy? This is the end of the input data, so that's not interesting. And the position of the output data is dictated by the position of the right channel. So that's also fine. That's also fine. The start offset B is right offset B. And this is updated every time you write. I think that's correct. Let's do this. Does that make sense? And then we so. Like so. Is this correct? This is only run once. Was it complaining that this isn't? Why this is redundant? Why is it redundant? Use the cardinal. We aren't actually checking this. And we should be encoding the deltas and not the values themselves in most of these cases. These should be encoded as is, but here we should be encoding the differences. Question is, I think this should be like 1 plus the difference, because otherwise we may end up trying to encode a 0, and these alias gamma and delta codes, they can't represent zeros. But this one is trivially not the same because we've checked that they're different. So yes, and this guy is also, actually we should check here, because if we have this same item twice, then why are we even writing it? Maybe we should like log or something here. Let's add a logger to this class. Like so. Unexpected what? Right. That looks correct. Is this doing what we intended to do? Let's go over it once more just to check. We're positioning the read channel, clearing the read buffer, that makes sense. We should be clearing the write buffer as well. Then we calculate how many bytes to be written. Actually, this is not correct. This should be like to be read instead. Actually, we should be using limit here. now we are decrementing the read pointer instead, and this is always written whenever it's filled up. We're always flushing everything to the compression logic. And then when this is done, we will finish up any lingering data. It seems like it might be correct. Like, did we have a test for this? Yes, we did. And this test is going to break, but that's fine. We need to implement it again, and this is the input file. So this is a bit annoying. Can we have like a rank component instead? Because we want easy access to this. Let's just test the logic for domain ID and doc ordinal first. We should be encoding like 0, 0 to ensure that this doesn't blow up. And then we have 0, 1. 1, 0, 1, 1. We don't really care about splitting this up yet, then we can remove this. Let's just see if it's all running. Yes, that seems correct. Can we do this? We now byte, and then we do the output file. We wrap this guy. Why would we want to flip this? I don't think we want to flip this. And then we do bit 3 there. So we're to get the 2 bytes, and then we should let's look at the code again. Where did we put this guy? Have we already removed the comment? That would be very unfortunate. Which should be in the copy buffer, I think. Right. So what's going on here then? Then we need to and get 31, and then we get the first order. So we expect this guy to be 0. Let's see how this runs. This 8, that's not correct. Do we want to flip this like it was suggesting? I don't know how it's positioned. Let's see. No, we don't want to flip this. All right, I need a short break. All right. Let's see if we can work this out then. See if we can work this out. What are we doing here? Right, I think we forgot about the size component in the test. Size reader, yeah, 30. And how much are we encoding? We are encoding 4, I think. All right, so far so good. Actually, what are we doing in here? This doesn't seem entirely correct. Rank domain kernel. Didn't we actually read the first rank? No, we did not. And so that seems correct. And then we read the handler. And then we expect actually, I think we should be doing it like this. We add our independent namespaces for this, scopes rather. And we expect the code to be, now we are, what are we doing this? We are increasing the document ordinal. So we expect the code to be 0. We should be doing this because we're going to be incrementing these guys. Like so. And when this is 0, then we encode, we gamma encode the ordinal difference. I think that's where we arrived, right? Yes, it's gamma. And then we do ordinal. Like so. Is correct. Yes, so far. And then we read the next guy, which should be 01 B. Sorry. Yes, this is 1B. It's not allowing me to do this suffix. All right then. Thought I was doing that a second ago, but maybe there's some additional constraints when you're allowed to do the binary suffix. Or did I just imagine doing this? I think I just wrote it in a comment and then I assumed this was Java syntax. Maybe it only exists in my head. Dreams of the syntax I want. Right, so code 1, then we are delta encoding the difference in domain ID, and then we are coding the difference in, or are we actually just, let's check here what we're doing. Yes, we're encoding the difference for both of them. We're adding 1 to the ordinal, but actually we can't do this. This is incorrect because this might be negative, so we should actually be doing this instead. And I think that's what I was doing in, I had this simulation code I had over here. Right, this is exactly what I was doing. I wasn't doing this, but I think that's insignificant. That's insignificant. Right. So, where are we? This is the first, this is here where we're looking at, this is delta. So, and then we expect the domain ID to be incremented by 1, and then we get the absolute ordinal, like so. And then we expect the ordinal to be 0. Yes, that's correct. And then we have actually this isn't actually testing anything meaningful because we're just doing this test again. Let's make one where we are encoding the rank as well. I think we can just do like so. Are we allowed to do this? Actually, I think the highest bit is reserved. We shouldn't be doing this. We should be doing this instead. Second highest bit. Because we want the sort order to be correct with signed longs. So we can't use the highest bit. That's forbidden. But if we set the second to highest bit, that's fine. That's modifying the rank. Yes, let's try this guy as well. And the code should be, what is the code for this guy? This is code 2. Then we get the difference in rank. This is gamma encoded. And then we write the uncompressed domain ID and doc ordinal. Is this questionable? I don't know. And we are not allowed to do this. This is illegal, so we should be doing 31. And let's have something more interesting than 1 and 1. Let's have 451. To let the world know that we are into insims. Like so. Nope, that's not correct. 112, that looks fishy. This isn't like just misaligned, it's picking up some additional data. Are we actually gamma coding this? Yes, we are. I think we should be, let's see, let's put a breakpoint here. Let's put it over here maybe. Let's see what we're actually trying to write. Right, and it's rank we're trying to watch. First 0, 0, 0, 112. Why is this decoding to 112? This is negative. Why is this negative? What have we actually created? This looks very, very strange. Document ordinal is 51, domain ID is 4. What the heck is going on in here? Actually, how is this negative? The highest bit should be 0, right? I copy this. And where are we? Let's evaluate this. Why the heck is this 0? And why is this negative? Now it's positive. Oh, this is of course setting the my hexadecimal isn't with me today. We should be doing 8. I think. How is this negative? Why is this negative? Because this sign, no. This is the, am I incredibly stupid today or what? This is what I want to do. Brain, no work good today. I should be knowing my hexadecimal. This is, of course, each digit is 8 bits, and so the highest ones are 8 and 16. So we have actually, why can't I reason through this? So each digit is 16 values, so we have 4 bits. And yeah, maybe this is correct. Let's see. Let's see. You should never be trying to do math live. That's generally a bad idea. Right, this is why are we getting 32? You will never seem as stupid as when you're trying to do math live, because then you will make the bizarrest mistakes. I wonder if what is this guy doing? It's pulling this guy down by 7 bits. This is bothering me. First of all, I should understand binary better than or hexadecimal better than this, but I'm right. So 8 is setting the highest most bit, and then every value from above is setting additional lower bits. That makes sense. So let's put a 7 then. Let's put a 7F. And then we have 63. Could be that this rank is encoded in some strange fashion. Right. And now we get strange values down here as well. And why is that happening? Is it happening when I'm doing this? Yes, it's happening when I'm doing this. Is it happening when I'm doing this? I don't know what's complaining for different reasons. I think I may be actually masking into the data, so that's, I think, fine. Maybe we should have something like this as well. Rank mask. So we're using 6 bits for this. That makes sense. This is a strange. Bit of a strange boy. Yes, it's between 0 and 64. That actually does make sense. 0 and 63 even. Right. So the problem is that I'm not understanding this codec and trying to encode larger values. But it turns out that if you keep it within the range it should be, then this should be actually working. I think if you're putting like 7 here, and this is such a nasty thing to be doing in your hand. Let's agree with 56. All right, let's not get sidetracked by this hexadecimal arithmetic. What we're seeing is that the codec, at least at the first glance, appears to be working when you put data into it that isn't complete garbage. So that's cool. That's not where I wanted to go. Let's go this, and then we go over here. Then we need to modify the entry source as well. And I think this might be a bit nasty. We're basically going to be doing the same thing. Except in reverse. So let's take a moment. We're going to need a buffer in this guy. So what do we want to do? We want to do what? When we create this, we should be reading at least the header and decide how many items we can read. And we probably want to overshoot reading the header a bit, so we reduce the amount of read instructions. That's correct. And we want a buffer for encoded data that we have read in the entry source somehow. That makes sense. Making some noise. Let's do 4K. That's a nice. Or should we be doing 2K because we're probably not going to be block aligned. Let's do 1K. We can tune these numbers later. In the meantime, we will have some size of data. It shouldn't be final. Because we're going to be updating this and we can't rely on the file channel maintaining its position over time because it's going to be accessed from multiple threads more likely. So we need to keep track of the position ourselves. So first of all, what are we doing? We are filling the buffer. File channel read. And then we are throwing an exception if everything blows up. We should be doing a try catch in here as well. Well, let's just rethrow it as an illegal state exception to get it into a runtime exception. Like so. So we are reading the data. Next we need a bit reader, and we're going to be reading the header. So this guy isn't doing anything at all when you initialize it, so we can do it all the way up there. That's fine. We're reading the data. And then we should be able to we can loop this while what do they call the buffer? Read data while it's smaller than 8. This might return 0 sometime, I think. Just to be sure that we have enough to at least decode the header. I don't know if it's at all possible that we're getting a 0 here, but since the Java doc indicates it, let's assume that this might happen. But I think in general I would probably just ignore the return value, but let's try to be rigorous for once. And then we do read red data, flip. All right, and now we want to decode the size field. So first of all, we get the code. And we should be moving over this nice comment again to have something to look at. So first we're reading 2 bits, and we want it to be 3. If it's not 3, then you throw an exception again. And let's assert it instead. It's like shouldn't ever happen. Like so. Like so, like so, like so. And this num entries, we don't need that, and we're actually going to be modifying the code to not provide that. Because now we can just read the first 32 bytes and 32 bits and strip the first 2. We will get the size, and we don't need it to be provided for us. Actually, we should just do this. All right. And now we're positioned. Now we are positioned. Right, so how do we want to do this? Because in the handler we're going to have a raw ID. Actually, maybe we should be decoding the handler all the way down here in the read function, which will be called repeatedly. But because it's prefixed by this 2-bit value that equals to 3, then we can assign num items when we see it, and then we just decode the value. Actually, I think that's a good idea, and then we don't need to have a final here. And we don't actually need really any of this. We can move the reading logic into this read method. Num items we can set to -1. Actually, we can even do it like this. We can read it in the header, but the way we read it is by, as I mentioned, buffer. We read 4 bytes and we read them at the start offset, and then like so. I think that should work. And then we can do we can also just do an assertion here. So we should be doing this. I don't think this is like realistically possible. We flip it and then we restore the buffer. And then we can delete all this code. I have some idiot on a dirt bike outside my window that's making a bunch of noise. I'm not sure if the microphone is picking it up, but it's annoying. We're having quite a bit of a problem with nuisance drivers around this part. It's like driving around making noise for the sake of it. Stupidly annoying. Right. Position. Why were we using this? I think this position and offset, I think we can delete those. They're not going to be relevant anymore. And this is the read offset. That's fine. We keep track of where we are in the file channel using the read offset. And we need to do that. Is this ever used anywhere? No, that's we should actually go to declaration. I'm overriding something here. This is never called, so let's mark it as deprecated and plan to remove it, because it's not going to be working when we are compressing the data. Right. All right. So what are we going to do in the read method? First of all, we need to check if the is correct. In some broad sense, this is what we want to do. I'm not sure if we want to do it here. I think initially we want to try to decode as much as we can from what's already in the buffer. I think if we do something like this, And if it's less than 8, then we try to read more. This is going to be a bit finicky because we're not entirely sure how much data we need, and we don't want to keep on reading beyond the data. So how can this be done? This part we don't need, and then we like this. So and maybe it's fine if we overread a bit, possibly. Right, so we're filling the buffer. And then as long as this, then we clear it, and then actually this is really bothering me. I should be having like a as byte buffer for this instead. That will clean up the interface quite a bit. I don't think the caller should be bothering about like the underlying data structures too much. That's a lot better. Right. So I think we can do this even. So while we have room for more items in the output buffer, actually, I think I need to do like this because we're going to be having this finish last byte call at the end, and we don't know how much it will write. It's typically a full long it's writing. So this should hit at least 2 longs. And now we do the whole thing we were doing down in the test again. We grab the code. We're compacting it. Yeah, this should be working, I think. We get the code selection item first. If code equals 3, then we need to first we just skip 30. And actually, I think we need this. We need to populate these guys, and in this case, we just we just get the items straight. It's so if it's too, that happens when it's too, then we gamma decode the rank. And this is actually, I realized this is incorrect as well. Because we may have rank 0 and we can't represent that with the gamma code. Let's just check that we're doing this correctly. All right. We need to do rank +1, and then we need to do rank -1 in the decoding bit. And this, like so, I think. Let's try. Let's hope it's not bothered by the obviously broken everything in here. So let's comment this guy out just to get it to compile. It would be very nice if I could run this completely unrelated test with this code not compiling correctly, but I guess the science isn't quite ready for that yet. Get gamma -1. Rank is previous rank. And then these guys are read and compressed. All right. And the next case is code 1, and then we are delta coding the domain ID. And this is, I mean, this is obviously quite finicky. All right. Well, why are we creating a bit writer? This doesn't really make sense. We shouldn't be emitting compressed items. So let's do this. let's do this, and then we need to basically put this together. Can you figure this out? Almost. I think we need to implement this method. Right. This we don't need. Like so. Then we should do this uniquing bit. We need to tell long query buffer how much data we have. Their method for this. I think I can just set the end like so. Why don't I have access to URL ID codec in here? Is it's not accessible, or is this just IntelliJ that's having one of its moments? Possibly it's not accessible from in here, but that doesn't really make sense because I'm accessing it from here. Let's copy it instead. At least it can find it now. So, and then we do. How much do we shift this guy? Is it like 57, I think? Right. This should be in here. I think that's correct. See? No. It's encode ID, it's not just encode. Like so. And then long encoded value. Actually, I think we can just do it like this instead. And then we update the previous values. Are we updating red items? Yes, we are. So we're filling the buffer up. We should be having at least a long in here. At least we're trying to read it. If it's less than a long, it will read whatever it's available. I think that's correct. And then we flip it. Possibly there's some assumptions within the bit reader on the position of the byte buffer position, but I don't think that's the case because we're basically just doing this read next method. It's just getting whatever is available. Yeah, I think that should work actually. And we're never reading more than a long. I don't think so, at least. Doesn't seem like that would happen. All right. Do we have some tests we can run for this? I'm feeling like my brain is a bit undervolted today. What are we doing here? This does not appear to be correct, at least. Right. Do we have something we can do to get some deeper understanding of what's going on here? It's not the transformer, it's the entry source we are messing around in, and this number of documents thing. We should be reading 4 bytes, and then we should mask out the highest 2 bits. I don't think that fixes the problem, but it's something that should be done at least. And get rid of this part because we don't need to do that anymore, and this offset is incorrect. Maybe that was the problem. Nope. Number data to read. Are we not filling this up as much as we should? Actually, maybe we can put, maybe this should be in a different method. So, and then we can throw an exception. We can keep it in the loop here as well. Maybe we should just do this instead. Nope. What are we doing here then? Bit reader is running out of data to be read. How much are we reading? Right. And we get some understanding of this from debugging it, maybe. I think I have my old breakpoint still as well. Yes, I do have my old breakpoint. Skip over that. So we have not read anything yet. Output buffer. Position 0. Buffer 0 limit of 6. We get the codes, and then we get the first value. When we skip the size, rank domain, and ordinal is all 0. This makes sense. I don't think it should be 0, but it's at least indicative of something. And then we can look at the. Sorry, I was looking at the wrong buffer, I think. This is the output buffer, so we're putting a long, and Annoyingly, it's using memory segment, so I can't quite inspect what's inside it, but we're updating the previous values. Fine. Now we are reading the second item. We're getting the code. It's not 3, not 2, it's not 1, it's ordinal brick. And is this where we blow up? Yes, I think. Right, so something is quite amiss over here. Right. I need to fill up my coffee, so I'm pausing this for a sec. All right, coffee is refilled. So what are we looking at? We're running out of data. This seems like the... Let's see, where are we? Where are we? We're getting the correct value for num items, and we're iterating twice. And we're only filling this up if it's less than 8. We're using compact incorrectly. What's it doing? The bytes beginning a position is limit or copy to the beginning. The position is updated to the end of the old data. And what happens to the limit? So here we have like this isn't quite the same scenario we have here. Or is it? I think it actually is the same. We're just doing this in not quite the same order. Right, so let's go into the debugger again. I think we should enter the fill read buffer. Is this true or false? And this isn't actually run. because initially the limit is set to the end, right? So we're not filling the buffer, and that explains why nothing is working as we expected it. That makes sense. So we need to do what? Read data. We need to set the limit to 0, I think. This might work. I have faith. It's still not working, but it's working better. And now we're getting 3 items, and that's not what we expected, and I don't understand why. So let's go into the debugger again, because last time we're filling up the buffer, and we are reading the code, and we are getting the full value. That's correct. And we are updating the values, right? And read items. That's correct. Correct. Right. Buffer and this 32, and the problem is what? Output buffer position. Why is this stupidly high? Why? I would expect it to be 16, but we're getting 32. So what's the deal in here? Let's not modify this, and let's just rerun this instead. Buffer position is 0. It's 8. Now it's 16. Output buffer is 16. All right. Maybe I was misreading it. I swear it said 32 a second ago. As mentioned, brain no working good today. So that's perhaps just how it is. Now that's correct. Now let's see what's the problem here then. I'm getting 76. So something is not decoding correctly. The first one is looking good, but the second one is looking a bit sketchy. Is there a mismatch between how we are encoding and decoding this? Most likely. Let's open them side by side just to see. Transformer. So in the first case, we are putting 7 bits of rank, 31 bits of domain ID, and 26 bits of document ordinal. That's correct. Next, in the case where the rank has been updated, what are we doing then? This is this guy and this guy. The code is 2. That's correct. Domain ID This is uncoded, and the rank or gamma encoding rank +1, and then we're actually this is not the delta in rank, it's just the rank. Do we want to encode the delta in rank instead of the rank? Yes, I think we do, because this should be smaller in general. And then we don't need to add this +1 because it's trivially not the same. Right. Let's consider this case as well. Or putting code selection of 1. Shouldn't be doing this. Just for clarity. Code selection of 1. Here we are. It should be in the same order. Otherwise, this is going to be very hard to follow. So, code section 1, what are we doing? The rank is the same, so we don't need to bother about that. The domain ID is the difference in domain ID the previous value. That's correct. And then we are, the doc ordinal should be delta encoded and not using the gamma code. So that's at least one thing that's incorrect. And this is just to make Java happy. This literally cannot happen, but let's add it in anyway. Right. So we looked at this guy. Now let's look at this guy. The rank is the same, the domain ID is the same, and then we gamma code the difference, not the absolute value. And then we don't need this guy. This is not domain ordinal, it's document ordinal. Right. Let's see what happens now then. Hello, we are working. We are working. Through the power of rubber duck debugging, we are working. And this is not supposed to be possible. I think we have some problem with the data, possibly. Let's just add some assertions for this case, because this is illegal. Stop right there, criminal scum, is what I want the Java to be saying. At this point, rank is not increasing. So, what's going on in here then? From each transform. Let's be super useful with this guy so we can get some visibility for what's going on. Where are we finding a rank of 50 in the first place? I don't think this is correct. But I think I saw entry more meta, creating a reader, entries. Right. This test code is a bit gnarly. Term IDs, positions, entry doc ID. Document metadata. I don't quite understand how we might end up with a rank of 50. Combined ID. I think something is incorrect in the writing aspect of this. Possibly. Right, we are adding. Let's. Can I do this? No, this isn't correct. It's not correct. This, I think. This is very, 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 very strange. Where are we getting this 50 from? I mean, obviously 50 appears in like the word ID. Let's see if I change this to 57. Does it haunt us? Nope. That can't be where it's coming from. Right. Is this like a something like that going on? Yeah, this is at least telling us that something is messing up here. Entry doc ID. Let's just print these guys out. Sure, this is not like in the data generation, even though I can't really understand why that might be. These are sorted in the reverse order, and that's not what I wanted. I wanted to do this instead. Right, so it's from 100 to right. Now I do wonder, this might be some issue related to how we are refilling the buffer, possibly. We are always emptying the read buffer, so that shouldn't be an issue. Let's do like 16 just to verify this hypothesis. This should fit in the buffer. Nope. Let's do 4. Because I mean, obviously this was not a problem up here when we had 2, so. Okay. Oops. And then it's 106, 108, but we are getting something else. So at least we have gotten rid of this haystack and gotten a smaller one to play in. Can we reduce it to 3 items? Yes, no, maybe. I don't know. Can you repeat the question? 110. It's obviously not correct. So what are we doing in here then? What are we doing in here? Should we be looking at the entry source? And these are all only ordinal. Seems like we are possibly is this the same with we do this? Oh, 46 is correct. The entry source again. Let's open. This is the transformer. I don't want the transformer. I want the entry source. Why? This is. Oh, right. So I had it open over here. That's where I want to go. We are filling the buffer. First, we are entering this case where rank. Well, how are we getting rank 50? I'm very curious about how this is happening because we should be writing rank 0. So something is messing up in here, the transformer. If the rank is different, we're gamma coding it. Well, actually, this is the first. Right, this is the code 3. So somehow we are encoding 50. We should be looking at this code. So can we first have a quick look in here, what we're doing. So get rank first item. How the heck is this 50? How in the heck is 50? What are we trying to write over here? 5000. This is very strange. Is this like an buffer endianness thing? Could that be the problem? Now we're getting 52. Yeah, I wonder if this is a buffer endianness thing. But why would that happen? It would happen because we are using long arrays and they are native endian. So how do we do this? Let's rerun this. All right, this is looking better. All right. And it's still incorrect because we are reading big endian as well, I think. Read it little endian. Let's rerun this. Now we're getting 0. But it's at least telling us. We have learned that the first problem of the spooky ranks was coming from an endianness issue. Right. And we want little endian, I think. We could of course convert it, but I don't think that's something we're interested in. So let's go back into the debugger. This is the writing part. You can skip over that. Okay, maybe we can't. Right. Entry source, what are we doing over here? I think we are source. think we need to look in here as well, see what happens. Num items, why is num items 0? Or should this be big again then? Let's check again, be sure. We're still getting 0. So now we are writing everything correctly, but what happens when we are getting the correct values? Red buffer. I think it should be like this, maybe. And we can skip over this. And where are we now? We're trying to read the num items. This is not correct. This should be big endian, or rather, whatever, Java endian. Let's try this again. Right, num items is 3. That I do agree with. Now we fill the buffer. Now we fill the buffer. Rank 0. Ordinal 100. Next item, we are blowing up because of what exactly? Trying to basically and this shouldn't actually be, we should just be doing this since if it's larger than 0, then we larger than or equal to 0, then we can do this. Or actually, we should be larger than 0. And then we flip it because it's not guaranteed to have more data. And if it doesn't, then we don't want it to explode. Actually, fine, nothing. All right, and this is not what I wanted. Holy crap, this is so finicky. I'm not really feeling my brightest today. That's how it be sometimes. Previous to the buffer. So what's happening here? What is that? It's a read buffer. We should be looking at position is 0, limit is 0. How did this become 0? Let's see. The code is 0. And this Oh, I think I actually mutated this because I evaluated it. That's fine. Let's finish this and rerun it. And there. Okay. Now we have backward 104. Shouldn't be doing anything. Code 0, code 0. Backward 110. Correct. It should be 106. Why is it 110? I don't know. And then we update the position. That should be correct. Now we are throwing an exception. Maybe? No? This is correct. Is correct. Inquiry buffer. It seems as though we put everything correctly, but we get nonsense out at the other end. Why is that happening then? Entry source. Is there a bug in this encoding function? I mean, rank should have been 0, so I don't really see how that might happen. We like can log this out somehow. Just to get some sanity checking. Right, so what we're putting in is not what we're getting out. Is this still some endianness nonsense? More than likely, right? Right, so now it agrees with what we're putting in. It's super annoying because when you memory map memory segments, they are native endian and not Java endian, which performance-wise is a good thing, but you end up with these disagreements between conventions, and detecting them isn't always the easiest. You get a feeling for it, but especially when there's abstractions around things, it's a bit annoying. Right, so it seems like when we are encoding this, what are we actually doing here? Putting the gamma, and then when we are decoding it, getting the gamma. So I think we need to pull these guys up side by side again. Transformer, low. No. So, right. Pull this up. Let's pull these up. This is looking correct, right? So is there some like error in someplace else? Are we consuming a bit somewhere, or are we there a bug in the gamma coding logic? Could this possibly be? I don't think there is, but this is delta. Let's go to gamma equals 0. And then we get bits plus 1. Putting 0. And then we are putting the significant bits. Is this correct? And we just let's do this. And what were we coding? We were coding four and 2, right? Right. Let's try to see if we can replicate what we are seeing in this test. That does not appear to be doing it. What are we actually encoding then? Transformers. Previous document over now. Let's see. This is the wrong test. This is the guy we want to do. We need to clean up a few breakpoints. I think they are a bit all over the place right now. Right. And this is what exactly. But I didn't open the search engine. I wanted to evaluate the expression. Thank you. First we're putting 4. That makes sense. And then we minimize this. Wait, what? We are actually putting 6. Why is this happening? Are we not updating the previous value anywhere? Well, that would explain it. We should be, of course, updating this. Otherwise, things are going to get very strange and bizarre indeed. Let's just run it now then. Holy crap, this is finicky to work with. It's not working. Expected 32, that's fine because we don't have 32 items. Let's see if we can restore this test. Let's show the diff. Revert this. And we don't need this sort, I think. So. We're getting 31. I think that's possibly something that might happen. Or is it? No, it shouldn't be something that should be happening. Right. And we can. I mean, this should be aligned with the long. It should be a multiple of 8 anyway, so we can just has remaining. Right, and we are printing a bunch of nonsense here that we don't want to be printing. Where did we? Where did we put this guy then? This is the wrong view. This is the wrong view, and this is the transformer. And is it over here that we're printing a bunch? No, we're not printing it here. Or did we add this to the test? Yes, we added it to the test. Oops, I didn't mean to open the debugger. But this is perhaps good because then we can remove a bunch of breakpoints. We don't want to litter the code with anyway. Right, so is this working now? I have no idea. This I've been chasing endian issues for so long. I don't really have a concept of what this code is doing anymore. But that's how it is sometimes. I think I will do the undisciplined thing and just try to run it. Because it will tell us at least something about whether this works. I think. Yes. Yeah, as mentioned, I'm not feeling very bright today. I think I'm coming down with something. And it's very helpful when you're doing stuff like this that you're actually your smartest. So let's do this. Let's do this. Do it the Anga way instead of actually being disciplined about it. Let's move this guy over. It's not up yet. But it should be in a moment. Right. And then we can do restore index back up. So we don't need to reprocess the data over and over again because we weren't actually changing the processing. Which one of these is the newest? This guy. Let's do this. And this is the civilized way of just reconstructing the index. It's full summer over here, and I don't have air conditioning, so my office slash or temporary office, and it's quite warm and humid, and that this doesn't really help with the mental clarity aspect of programming, unfortunately. Right. Did this work? I think it in. We're not getting any exceptions, so let's just go over here then. Not debug, search, test. So we are at least not getting any exceptions. And we unfortunately can't really tell. We can't really tell if it's shrinking the index data quite yet because it's too small. So what I need to do, first of all, to flush out bugs that may or may not exist when filling up the buffers, but also to test with more serious data. I think I need to push this into the branch and then deploy it to the test environment. Is there some additional testing I can do, or should I just send it? Because as I've been complaining about for a while now, I'm not feeling all that well. Let's wrap this up. I think we can force push this later and clean up any mistakes that were happening. This branch is very, very far away from going into the master branch anyway, so I think it's fine. And it's a considerably messy change anyway, because I'm changing a lot of the index structure and so on. So if there's some gore in the middle, I think that's fine. Right, so what have we done? And the compression to the priority index. Where did I put this? Let's just leave the schema in here. So we have it somewhere. Yes, this is not very disciplined, but I want to wrap this up. Been going for almost 3 hours, I think. I need a break. So let's push it. And then let's log into test environment, and then we'll build and bring it online. It's going to take a fairly long while to reconstruct the index, and most of it isn't actually this new code. Some of the older code is still quite slow, so it's taking like a couple of hours to do this, but it's for like a considerable amount of data as well, so it's it's okay. I want the index construction to be faster, but we pick one battle at a time. Right, and now we are online. The new code, and I had actually already brought this up, so then we can do the same thing over here. And I will be monitoring this to see if there's any exceptions and so on going on in the logs. I don't expect there will be. Actually, there may be some bugs hidden this in the. This is perhaps not my most well-focused change ever, but We have good days and we have bad days, but on most days we commit code. At least it's good to be sort of aware of where you're at. Right, so we have deployed this fairly shaky change now, and we will see if it's something we want to keep. It will be interesting to see, in a way, to see how much it compresses the file. This is actually the simulation I built the other day to see how small the index will get. It's compressing the data, but not actually compressing data. It's just basically calculating how much space we would need. Right, getting sidetracked. I should be wrapping this up because my focus has gone out the window for like an hour or more. So I don't think you will get much more coherent thought out of me today. Let's see how things are in the future when we have actually the results from this stuff we're running now. And maybe I should add like a button for only constructing the priority index. That would speed this up quite a lot because most of this is waiting for the full index. But anyway, I'm rambling, and I should be wrapping this up. So goodbye for today.